All right. Okay, so here we go. What we're going to do to begin with, we're just going to take a look at the Junos operating system and its basic design architecture. So you'll notice, first of all, that the operating system is called Junos. Now, if you compare that to Cisco's, their operating system is called iOS. Okay, so this is kind of like the Juniper iOS, if you like, okay, called Junos. So it's called Junos. We're going to take a look at how it works. The basic structure of it. We're going to explain traffic processing for transit and exception traffic. What do I mean by that term, by the way? What is transit traffic? How would you describe transit traffic on a networking device? Any ideas? It comes in one interface and it goes out another interface. It's transiting, okay? That's most traffic, isn't it? I mean, that's the whole point of the device, is that maybe one interface is connected to the internet, maybe the other interface is connected to my internal network, and therefore the traffic that goes through is transit traffic. So this is like normal network traffic, is transit traffic. Exception traffic is stuff that maybe when I'm logging into my device to manage it, that's exception traffic, because that traffic is not transiting, I'm logging in, so it's going to the device itself. And we'll take a look at a brief overview of different devices that Juniper make. Okay, so we're going to get into the Juniper operating system, look at traffic processing, and overview of the devices itself. So first of all, the way that the operating system is designed, it's in a modular fashion. So we've got protocols, interface management, chassis management. We've got our monitoring down there, SNMP monitoring, and we've got security services. So each of these are a separate module within the operating system itself. And it's extensible, so you can add additional components to the operating system as you go. The beauty, and one of the great things about Juniper devices generally, is it's the same operating system that is used on all their devices. So whether I am configuring this device here, this J2320, which is just a router, fairly low-end router, or whether I'm configuring a massive router in a data center or a telecommunications company, it's running exactly the same operating system. But some of the gear we're configuring in our racks are about this big, little SRX 100, okay? It runs exactly the same operating system, exactly the same commands as some massive bit of gear like that, TX Matrix device there. So the beauty of it is, once you've learnt the commands, you can go to any bit of gear and configure it. It's exactly the same commands. Cisco have attempted to do that, but they haven't done it as successfully as Juniper have. Juniper have really got like the one OS across absolutely everything. Okay, now let's talk about this concept here, separation of control and forwarding. So, what is control? What is forwarding? Well, control is where you go in to configure the device. So, for example, when I went in there and said reboot, I was in the control bar. When you log into the device and you are managing it, what you are interfacing with is this control part here, the routing engine, the operating system, all of that there is what's called that control plane. That's the bit that you go in where you set things up. You might set up routing protocols, configure your interfaces, put security policies on, etc., etc. Okay, so all of the things that control and configure the device are done in the control plane. The forwarding plane is the bit that actually forwards the packets. Okay, so the way that the devices are structured is that the control plane is separate from the forwarding plane. And there's a lot of benefits to that. One of the main benefits is that whatever you're doing up here in the control plane, there's no effect on the actual processing of traffic at all. So we're happily forwarding traffic, which is what the device is supposed to be doing. We can be happily forwarding traffic without that being affected by what's going on up here in the control plane. In actual fact, in some of the bigger devices, you can do a software upgrade here without affecting anything that's happening down here at all. So you can do a complete upgrade of the software and the data keeps forwarding out happily. See, the thing with Juniper devices is they are designed to be in a telecommunications environment where it is an always-on environment. So you can't say, oh, I'm just going to shut down, you know, do a software upgrade. No, sorry, can't do that. It has to be always on, and so it is designed with an always-on concept. So essentially, what happens is we've got the routing engine up here. We've got this thing called a routing table, and we've got this other thing called a forwarding table. The routing table populates the forwarding table. You're all familiar with the concept of a routing table from Cisco. Okay, we've still got a routing table, but the routing table. Oh, hello. It's dropped out. Never mind. We don't need you anymore. Cancel. Okay, so what happens is the routing table controls the forwarding table, and we've got a duplicate copy of it up here in the control plane as we do down here in the forwarding plane. So basically whatever goes into the control plane gets pushed down into the forwarding plane. So we've got our forwarding plane there being a very, very stable forwarding engine, forwarding packets out. On the bigger devices, this particular part of the device is actually hardware, not software at all. It uses a thing called an ACIT, which is an application-specific integrated circuit, which is designed specifically for packet forwarding. So this process down here, all this what's happening down here, is not even happening in software. That's basically happening in hardware on the bigger devices. So it really pumps out the data at a very, very fast rate. And all that happens is that this control plane then programs, if you like, the ASIC for its forwarding functions. So there's a few other benefits to that. Like, just say, for example, I am doing like a debug operation, okay, where we're monitoring events or monitoring an interface or monitoring a protocol to try and log it or fault find it. The beauty of this is I can be doing that up here in the control plane without affecting the forwarding plane at all. So in other words, I'm not taking resources away from the processing of traffic to do monitoring operations. Okay, now if we had all that together, we would be, just say, for example, on some of the devices we looked at in our Cisco course, where you've got a router and we're just basically running off the routing table that's in our device. If you were to put debug on and start debugging something, you'd be generating a lot of overhead on that router, which would or could impact the actual forwarding of traffic. Okay, so with Juniper, it doesn't impact it at all. Whatever you're doing up here in the control plane cannot interfere with what's going down there on the forwarding plane. Okay, of course, if you misconfigure something, yes, you're going to interfere with it big time. But what I'm saying is, you've got these two planes which are actually separated. Okay, so what is the routing engine? Routing engine maintains routing and forwarding tables, controls and monitors the chassis, and manages what's called the packet forwarding engine, the PFE, packet forwarding engine. And down here, we've got the packet forwarding engine, and it uses layer 2 and layer 3 forwarding tables provided by the routing engine to forward traffic to its destination. So we can implement various things down here, like policing. Policing is, what's policing? Policing is say, okay, you've got an absolute data limit of, or your bandwidth limit is this. Your bandwidth limit is set at 10 megs, that's it. That's all you get. And you can set that for a particular network, or particular network destination. So policing, stateless firewall filtering, and class of service. What is stateless firewall filtering? Example of that would be an access control list. Okay, Okay, when we did access controllers in Cisco. All right, that is a stateless firewall filtering or stateless firewall filter implemented down there. Class of service. What is class of service? Class of service is where we are prioritizing certain types of traffic over other types of traffic based on giving it a priority. So we're going to say we're going to give voice traffic priority over regular data traffic. Okay, that's all done down here as well. It's all processed in the packet forwarding engine. Okay, which I said in the bigger devices is actually hardware, not software. So we're actually running chips down there to add that. The other thing is that on the really big devices, when you add interfaces, you plug in a separate card to add the interfaces. Those cards have got their own processing on them as well. So the more interfaces you add, the more processing power you're adding to the device. So every time you add interfaces, you're adding the processing that goes with it, which is this packet forwarding capability. Okay, it gets added in as you add more cards and more interfaces to it. So you're not, by adding interfaces, you're not overloading the device, because every time you add it, you're adding more capacity, more processing capacity as you add the interface as well, to support, of course, the interfaces that you're adding. Okay, so separation there of those two planes. Traffic processing. We've got our routing engine there, so we've got our CPU up there. Now, transit traffic is forwarded through the local system. The packet forwarding engine uses the forwarding table provided by the routing engine, and the examples of transit traffic can be unicast and multicast traffic. So, as you know, unicast traffic from one destination or from one source to one destination, multicast from one source to multiple destinations. Okay, so unicast comes in one interface, goes out another interface. Multicast comes in one interface, could go out multiple interfaces. That's fine. So that's all handled by the packet forwarding engine there. The exception traffic is processed by the local system. So it goes into an interface from the packet forwarding engine up into the control plane. Now, exception traffic is stuff like when you log into the router to configure it. Okay, so I've got an SSH connection into the router. What's happening is I'm coming in through an interface. So I'm coming in through my management interface, which may be interface FE000 in this case. It's coming in through here, and then it's sending it back up into the control plane here. So you're actually then controlling the router up through the control plane. That's called exception traffic. Sometimes when you've got to generate an ICMP message, it'll be done up from the routing engine as well. Okay, like a ping, something like that. Or some kind of destination and reachable message, something along those lines. Okay, TTL expired, there's an example of that. Okay, all right, so exception traffic is rate limited on the internal link to protect from DOS attacks. So it just stops the router control plane from being, inundated with those kind of attacks, just in case you get a DOS attack on your router. The control traffic has preference over the transit traffic if congestion exists. So if I've got control traffic coming into an interface and the interface is congested, that will actually be prioritized over transit traffic. So transit traffic will be dropped and control traffic will actually go through. Okay, let's take a bit of an overview of the various devices that Juniper make. So we have got switching, routing, and security. The device that we're using, SRX, falls into the security category, even though we're going to be using it as a router in packet mode for this particular course. It is actually a security device. And there's all kinds of different levels and sort of sizes of these devices for different applications. Got the MX MX series devices. These are kind of really high-end for telecommunications companies. Will use those devices to provide services like VPNs to their clients and secure channels, secure tunnels through to their clients. Runs protocols like MPLS. We will be using this when we do our MPLS course. We'll be using virtualized MX devices. You've got other devices like the ACIT series, which is kind of a hardened device. It's designed for it to be sort of in an area where you've got maybe humidity, maybe it's not inside, maybe it's in a construction environment somewhere where there's some fairly not lovely air-conditioned sort of environment like most routers are in. So that's kind of that one. This LM series, kind of thing that you might put into a vehicle, for example. Let's say you had to have your vehicles to be remote control. Like nowadays, for example, if you go down to a wharf, you've got your massive devices, like robots, I suppose, that unload the containers off of the ships. Okay, now they're completely remote controlled, and essentially they're guided by the IT systems. And they'll actually go and unload containers off ships and reload containers onto ships, racing up and down the wharves. And they're all controlled from your IT system. So they've got kind of these devices in them. If you go to a mining site now, you can see the massive mining trucks that are running around the mining sites, totally controlled by IT systems. And potentially they can even be driverless. Different routers, M-series routers, T-series, just for different applications, different throughputs, etc. So the EX are the switches. These are our switches. These are our base level switches, EX switches. Then the QFX switches are sort of the higher end switches where you will kind of have a whole switching eco-structure with a whole bunch of QFX switches kind of all connecting together, communicating with each other, acting like one big switch. And your EX switches are just the much smaller ones. J-series routers, the device that we use in our rack, which has got all of those virtual routing instances in it, is a J-series router. It's a J2350 router that's just sitting in our rack. So that is the device that all of you are interacting with when you're doing your labs. And you've got, as I said, all these virtual routers inside of it. So they have the capability for that sort of thing. Then we've got our SRX series, which is the device that you guys are going to be actually using. You are logging into an SRX device. These are fairly big ones we've got on the screen there. Ours are somewhat smaller. But the main point is they run the same operating system. They do exactly the same thing. Okay, so what you can do on a small device, exactly the same commands for a bigger device. Okay, so we've had a bit of a look at the operating system, basic design architecture, had a look at how transit and exception traffic is processed, and had a bit of an overview of some of the Juniper devices. Of course, they're always coming up with new devices. If you go to their website, juniper.net, you'll be able to see everything that they've got up there now. All right, some of the review questions. What are some of the advantages of the Juniper operating system? What advantages does it have? There's a few advantages that it has. One of the main advantages, what was that? Security, yeah. Well, yeah. One of the main advantages of the operating system is that the same operating system is used across all the devices. So if you learn how to use what we're teaching for the SRXs, you can go across to a J-series router or an MX series router or any other type of device and know that the same commands will work. Okay, now that device may have different functionality, so there may be some extra stuff, but all the basic stuff will still work. Okay, all those commands are completely transferable. Primary functions of the control plane and the forwarding plane. So we've got these two planes. we've got control plane, and we've got the forwarding plane. Okay, so what does the control plane do? Or what does the forwarding plane do? Let's start with that one. That's probably the easy one, isn't it? It forwards traffic. Okay, so it's just there. So traffic comes in, does a lookup, says, okay, I'm going to send this traffic out a particular interface, and it sends it out. Okay, so that, as I said, in the bigger devices is done in hardware processing using an ACIT. So essentially, it comes in, does a lookup, boom, out it goes. So it does it extremely quickly, okay, because that's all it has to do. Control plane is where you go and set up your routing protocol. So say we're going to configure OSPF. We will go and configure OSPF in the control plane. We'll set all that up. OSPF will actually interact with other OSPF routers, gather routing information, build the routing tables, do all of that, populate the forwarding table, and that will then go down into the forwarding plane and instruct the forwarding plane as to where to send stuff. Okay, so the control plane is where the operating system's running, where all the configuration is going on in the control plane. Okay, transit traffic. How is transit traffic processed? Well, essentially it comes in one interface, does a lookup, and just gets sent straight out another interface. Okay, exception traffic. What happens to exception traffic? Comes in an interface, and then it gets sent up into the control plane for processing. So maybe we're configuring routing protocols or whatever we're doing. And name the 3 platforms that run the Juniper operating system. Look at a few there. Should we go back and cheat? Let's go back and cheat. Yeah, there's some platforms. So we've got the J series, we've got SRX, we've got EX, QFX, MX, T series. So there's a few different series that they run. And that's it. Okay. So there we are. A little bit of intro into Juniper. What we're going to do in our next lesson is we are going to get into looking at commands, looking at how to navigate our way around inside Junos, kind of get the structure of it. I'll do some demonstrations of that as we go, and we'll kind of just get the hang of how to use the operating system. The first 2 labs that we do are really basic. We're just going to kind of get familiar with how's the operating system work, how do we get to it, how do we configure it, how do we navigate our way around in it. Okay, so that's what we're going to be doing. Any questions so far about what we're doing? Okay. With the numbers of students that we've got in the class, we will be running our lessons here on a Tuesday, but our labs will be back at the ACIT campus, okay, on the Wednesdays and Thursdays, right? Because that's more convenient to run it from there for everybody. Okay, so Wednesdays, Thursdays, the labs will be there. I'm quite happy for you to organise to do your labs remotely. Okay, as long as you get your team organised to do them remotely with you. I've done the labs remotely; they work very well. I have had connections into the lab gear, and we're just chatting on Skype or whatever, whatever you like to chat on. Skype works, but yeah, whatever works. I'm quite happy for you to do those remotely if that suits you better. Okay, it's just as long as you do them. It is important that you do the labs, okay, because as we go on, we move up into higher level types of things, and we kind of assume that you know how to do the basics when we get to that point. When we get to the high level things, we're not going to go back and teach you again how to configure interfaces or how to put addresses on interfaces and stuff like that. That is the basic stuff we're going to learn now. Okay, we're not going to go and teach you all of that or how to configure a routing protocol and stuff like that. We're going to learn that now in this 6 weeks. When we get to the high level stuff, we're just going to say, okay, just do that, okay, as part of something else that we're doing. Right, so I want you to practice these things, learn how to do it. These are good skills to have. Okay, now one of the advantages of learning another platform as well is that the concepts that we learn in the CCNA, you implement another platform, and what you begin to understand is that things that we did are not just Cisco things, okay? They are networking things, and you know that if you can do that on a Cisco device and you can do that on a Juniper device, you pretty much know it doesn't matter what device you come across or what bit of gear someone throws in front of you when you get into a workplace. You know you're going to be able to get into it, you're going to be able to figure out how to configure it and make it do whatever it needs to do. Because most devices use something like Cisco or something like Juniper or some combination of those two things, okay, in using them. So it's sort of in between that. Juniper was designed mainly for the high-end telecommunications environment. One of the things we're going to learn about Juniper is that the configuration works in batch mode. So, for example, if I go into a Cisco device and I go onto an interface and I say your address is 10.10.40.15, enter, and give it a subnet mask, enter, bang, that's the address. It's there now. So I press enter. With Juniper, it's not like that. You go and configure up all kinds of stuff, and nothing goes live until you say, I'm ready for you to go live now. Bang, go live. So the beauty of that is you can configure lots of different stuff, check it all, make sure you're happy with it, say, yeah, that's all good. There's even a little checking process built into the operating system that will actually check your configuration for you. And say, yeah, that's all good, go live now, and it'll go live. So the advantage of that is you can actually have multiple devices, and you can put configurations on multiple devices and have them all go live at the same time. So your whole environment will switch over. And so it's kind of designed for that kind of concept in mind. We're going to get into that, see how that works after lunch. Okay, so let's take a lunch break. 11:57. We'll come back at 1 o'clock. And away we go.